Hi, welcome to my little talk. It's quite a full one, so I'm not going to beat around the bush. I'm going to get right into it. This is really about the brave new crypto world. I want to sort of explore a few things, particularly how sovereign chains can interact with each other in this new model, particularly with respect to the new sorts of functionality that Polkadot provides. I think it's reasonable to characterize much of the progression of blockchain from being very currency-oriented, cryptocurrency, over to being more political, more sort of general decision-making oriented. And that's something that I think will continue into the future, and I think it's a very interesting trend and one that's critical for society at this stage. Before I get into sort of the main sort of points, I want to talk a little bit about Polkadot, because I think it's only by understanding how Polkadot changes things that we can really understand how the ecosystem as a whole is going to change. So Polkadot is a scalable heterogeneous multi-chain. What does that mean? Well, it's scalable because we have lots of different we parallelize a lot of the execution, a lot of the transaction processing within Polkadot, and we do so in a way that doesn't really depend doesn't really have a sort of upper limit in terms of its eventual degree of parallelism. It's a multi-chain and it's heterogeneous because each of these pockets of transaction processing logic don't specify the kind of fundamental kinds of transactions, rather they leave it entirely open-ended to the underlying team or developer or project, whatever. This gives an unprecedented level of flexibility, much more so than the sort of dynamic resource, dynamic metered model that Ethereum gives, although Ethereum, of course, was incredibly important at the time. This allows for not just the kind of smart contract model, although it does allow for that, but to be used, but also for more fixed function pipelining, fixed function transaction processing to be done that can give much greater performance gains. Now, Polkadot also has an emphasis on governance and upgradability, two critical elements I think you sort of, I hope to convince you of by later in this talk. So Polkadot's really the first of its kind. It's a platform for creating trust-free systems, not unlike smart contract platforms, but it really aims to give much greater technical guarantees, technical facilities in terms of flexibility, performance, and the underlying security. It's, I think, not tremendously unreasonable to compare the sort of transactions per second. Bitcoin here with, realistically, it's somewhere between 2 and 4 transactions a second. I put 5 because it has managed to get up there. But realistically, at the base level, without any tricks, no lightning network, no ZK snarks or start tricks, or, you know, at its basic level of computational performance, which can obviously be increased and improved across all chains by using these tricks. But at the base level performance, we're looking at around 5 transactions per second for Bitcoin and not very much programmable functionality, about 25 transactions per second for Ethereum, but obviously with much more programmable functionality, although the more you use it, the worse it becomes. Kusama, about 1,000 on its base chain transactions per second, with the programmable functionality being much more well, highly performant. I mean, this is the programmable functionality that we're looking at. This is using a WebAssembly base layer, which I'll go into in a second. Polkadot, because it has the parachains, and Kusama will eventually have parachains, but I'm sort of talking about Kusama right now. Polkadot, once it has the parachains, will be scaling up to maybe 100,000, up to maybe a million transactions per second, and I'll quickly talk about that. How will it do that? 1,000 transactions per second on the parachain, 100 parachains, 100,000 transactions a second. 100 is probably quite conservative. We've done some design upgrades. Probably it's going to be, I think it might get up to maybe even 200 parachains. And there's all sorts of further optimizations that we can do in terms of the database and I/O storage layer, the WebAssembly interpreter layer. This is all fundamentally on a meta protocol platform, which means it's upgradable. And also multi-threading. We do aim to bring in multi-threading to this, which will allow much better use of these sort of 6, 8 core CPUs that we're seeing increasingly prevalent. Polkadot is fundamentally upgradable. It's governable, unlike basically most of the chains. There are 1 or 2 that could maybe make this claim as well, but Polkadot does it in a little more style, I think. It's a WebAssembly-based meta protocol. This means that the logic of Polkadot is placed actually on the chain, on Polkadot. Polkadot hosts its own logic. It's a bit of a crazy idea, but there it is. And it's able to do this by using WebAssembly. WebAssembly effectively allows the algorithm or the protocol to be described as data, right, as instructions. And it's used for both the parachains, these shards, these individual parallel transaction processing units, and the relay chain, so the thing that cooperates and coordinates between, that allows these guys to cooperate and coordinate and gives them their security. Because we use a meta protocol, we have seamless upgrades that are controlled by the underlying logic of the consensus, the underlying logic of the chain. So the chain's logic can dictate what the chain's logic changes to, can dictate its own changes. In essence, it has control over its own destiny. What do we call this? I think agency is a really good word, right? Agency is how we describe things that have control over their own destiny. Upgradability and governability changes a chain from something that doesn't have agency to something that does. So what's a token? We need to sort of really dive into this, I think, in order to really understand how tokens are, or token economies are able to interact with each other at a sovereign level. Now tokens I've seen described, or token economies I should say, it's kind of a funny dichotomy here, but token economies are described in one of the three C's. Commodity, currency, or corporation. Commodity is kind of the dumbest. I think the three C's, to pin a protocol on there, we have to, it depends on the protocol itself, the fundamental protocol of the token, not any derivative protocols where token derivatives might live or be exchanged. And I think understanding whether a token has agency is the critical sort of difference between the three. So at the top level, you've got commodity, dumb chains, right? No agency. Bitcoin sort of loudly, or many of its adherents loudly advertise Bitcoin as basically having no agency, right? It doesn't do anything beyond its stated original goals. Bitcoin is meant to be this kind of digital natural resource, right? Digital gold is often how it's been described. It isn't managed, right? No one is going to take charge of Bitcoin and change its underlying economics. That's kind of its point. Currency is I think where you've got something that's a bit more managed. It's maybe a little bit more like something that has a central bank behind it, where the central bankers can make decisions on maybe the inflation or other very limited characteristics of the chain, but still things that are not fundamentally controlled by its logic. Corporation is the final one, and this is really where it has full agency to change itself, where it's an amorphous protocol. And this is the sorts of thing that sort of great companies have, the ability to reinvent themselves. Microsoft, at least as you know, sort of software developer, I've seen Microsoft kind of reinvent itself from the 90s, where it's sitting on its cash cow of Windows and Office, and it's doing its best to stifle any competition, into the sort of company that it is now, that's much more forward-looking, much more cooperative, and I think it's a really nice transition. Nokia as well. If you sort of look at Nokia's history, it's reinvented itself countless times, and it's this agency that allows it to do that. Now, if we look at models of mergers and acquisitions, and how we might apply them to tokenomics, I think we've got kind of two rough models, and I wouldn't really call one of them mergers and acquisitions. So the gold standard and even the ETH1 to ETH2 transition, where you do have two separate systems. Both of these two, I think, are derivatives. The USD being a derivative of gold, of course, originally. Discontinued for many decades, but originally. And the ETH1 to ETH2 with ETH2, the ether of ETH2, one-way peg, so it allows ETH1 to be burnt to populate the ETH2 economy, but still, because it can't go back again, ETH1 doesn't recognize the ETH2 minting process. Really, these two are not mergers and acquisitions, they're derivatives, right? We want to understand purchases, and I think the Eurozone change did actually allow us to see how that might happen in terms of a currency, but only when you really do have a large degree of agency between the constituent, powerful, controlling elements of these currencies. It needs a currency. It can't happen with a commodity. Why? Because there needs to be agency. We need a way of allowing an economy to act on its own behalf, act as a whole. On behalf of its various stakeholders, whatever. And if you don't have agency, then there's no way you can do this. In the same way that ETH1 doesn't have agency over itself, right? So there's no way how ETH1 could agree to some of the network's minting process, even if it's ETH2. How do we complete a merger? Well, it's difficult. Initially, you've got to sort of agree to the terms of the merger, and this must obviously, because chains are machine executed, they have to be machine readable terms, indeed machine executable terms. Now, generally, this is probably going to be fixing a price. Beyond that is where it gets really technically difficult. Chains have to respect each other's tokens. So basically, if once two chains have, sovereign chains have agreed on their price, then these sovereign chains have to make themselves, in some sense, subservient to each other. They have to respect each other's token base. And more importantly, they have to respect the logic that creates those tokens. If one chain has a bug in its token creation logic and somehow allows a validator to mint tons and tons of tokens because of some overflow or some other thing, then it has to respect that. Like, fundamentally, it can't just sort of say, oh, I'm ignoring you now, on its own terms. Big problem. In some sense, there has to be some shared idea of sovereignty that they both respect. And finally, if they want to share their token, which I think they will do eventually, they will need to, because having two separate tokens that just happen to have a fixed price doesn't really constitute a merger, right? Company merges, it doesn't just allow shares to be bought and sold at a particular fixed price. No, the company merges because it wants to make a single company with the best elements of both. And that again requires some fundamental underlying shared security layer, shared layer of consensus that allow them to have a shared destiny. Polkadot facilitates this by being an underlying platform for blockchains that allow them to get their own shared security, their own underlying consensus, without restricting in any way what they can do in their own deterministic, logical execution. And this is what gives Polkadot its underlying value as a system. It allows sovereign chains to interact without prejudice in a trust-free fashion. That's how I see mergers and acquisitions. That's how I see Polkadot helping in this regard. I hope the talk has been enlightening, or at least given you something to think about. And I hope we all see some of this really interesting stuff happening in the very near future. Thanks for listening, thanks for tuning in, and I hope you enjoy the rest of the conference.